Very good morning. It has been yesterday we have been discussing about the certain aspects of the embedded system where we have seen the operating system hierarchical side. If you see, the bottommost will be the hardware, followed by over which we have a kernel operating system, over which we have certain application software has been built in. Whoever wants to access any of the device has to give a command to the kernel. Kernel has to in turn uses the device drivers, and these device drivers will drive the particular device which of its interest. So therefore, it has been a good production has been made here. Nobody can access any of the device of the user application. So therefore, always we have to route it through a kernel, which has been much useful for us. Here we have been just want to say, highlight the device drivers is a piece of software that acts as a bridge between the operating system and the hardware. Because what I could see is that it is just an interface between the hardware to the kernel point. There will be a device drivers have been placed, which gives rise to one particular device have been activated. So therefore, I can say that the device drivers are nothing but a software which acts as a bridge between the operating system and the hardware. The user applications talk to the OS kernel for all necessary information exchange, including the communication with the hardware peripherals. So therefore, what I could say that the user application can talk only to kernel, not to the device. Therefore, the kernel in turn will invocate the device drivers of the particular device. So therefore, the OS kernel is having much importance here to actuate or activate any of the devices of our interest, which is been referred as the hardware peripherals. The device drivers, when you talk about, the architecture of the OS kernel will not allow a direct device access from the user application. All the device related to access should flow through a OS kernel, or OS kernel routes it to the concerned hardware peripheral. That's what we have been discussing. Because the outermost application software, which is nothing but user software, cannot directly access any of the device unless and otherwise the kernel gives a path on which gives rise to a device drivers has to be activated of that particular device. So therefore, the device drivers have been having greater place to bridge the gap between the kernel to that of the devices. So the OS provides interface in the form of application program interfaces, which is called as APIs for accessing the hardware. So it's nothing but an interface where it can be compatibility has been established so that the commands can be routed through properly, so that the particular interrupts can be activated, and which in turn can activate the hardware. So that is the meaning of it here, where it has an interface has been placed in between the hardware and the kernel, which has been nothing but APIs. The device driver abstracts the hardware from user, abstracts the hardware from the user applications. Okay. The device drivers are responsible for initiating and managing the communication with the hardware peripherals. Okay. So device drivers are responsible for initiating and managing the communication with the hardware peripherals. So what it means to say is that there should be, though we say in terms of interrupt has been done in that particular device, it has been programmable, and afterwards there should be a communication between the device. After the accessing, it has to give back a feedback communication to the kernel so that device is in operation. So therefore, the very important fact here what I could see is that apart from interfaces here, one has to see the establishment of communication has been very important. The drivers which comes as a part of the operating system image is known as built-in drivers for onboard drivers. Example, NAND flash drivers, etc. So therefore, the part of operating system image has been built in drivers into the operating system. which has been used and which is called as onboard drivers are available. The NAND flash drivers is an example what we could quote. The drivers which needs to be installed on the fly for communicating with add-on services are known as installable drivers. Okay, installable drivers. So we can installation can be done at any time of the drivers is possible because we will simply replace the particular software of the particular device drivers. For installable drivers, the driver is loaded on a need basis, which the device is present, and it is unloaded, the device is removed. When a device wants to be accessed, so it is called a loading process. A particular device will be loaded by the driver, and once the purpose is served, after the purpose is over, immediately it should unload that particular device and which has been detached from the kernel. So therefore, the kernel, what I could understand is that the kernel will have a small softwares associated with the device drivers, which activates the particular device drivers, in turn a device, as and when there is a necessity for the system to operate, or as and when the application software requests for a device to be accessed, the kernel does the task of accessing the particular device. The device manager services of the OS kernel is responsible for loading and unloading the drivers. Therefore, who does the task now? Loading and unloading of these drivers will be done by a device manager. So device manager services have been available within the kernel. These device manager services has to take care of which device has been brought in and which has to be sent back to the original position will be understood by the device manager drivers. So therefore, the underlying implementation of device drivers is OS kernel dependent. So therefore, what I could say is that the device drivers are dependent on the kernel. The driver communicates with the kernel is dependent on the OS structure. So I have already seen a OS structure which has been given as a device drivers is been placed in between the kernel and the devices. So that is the architecture feature of the OS structure which has been available for kernel type of operating system. So as you know that the kernel has been different kernels can be there for different dedicated purposes. Therefore, the kernels, all the kernels all together will work on real time because the device has to be operated in real time with a synchronization. So therefore, one has to be very careful to see that which device has to be selected. There will be proper communication between the device and device drivers to the kernel so that appropriately the device will be selected and which will be placed back. So the device drivers can run on either user space or kernel space. So where it can be placed is one, I said all this time, the kernel will make use of the device drivers. These softwares will be placed either in the memory space of the user or the memory space of the OS. So therefore, the device driver software can be fused into the kernel space or to the user space. Device drivers which run in user space are known as the user mode drivers, and drivers which can run in the kernel space is called kernel mode driver. There are two modes of drivers. One is the user mode, other is the kernel mode, depending upon the placement of the software, where it has been placed in a user mode or in the kernel mode memory. So user mode drivers are safer than kernel mode drivers. This is because what I could see is that user mode, when the software has been placed into space of the user can have access over the drivers, whereas the kernel, one has to be routed through a kernel. So this is the tedious task, and there will be a chance for a kernel will be corrupted. So therefore, the user space drivers, user mode drivers will be preferable than kernel mode drivers. But as far as the microkernel is concerned, it has been mostly the kernel mode drivers have been available, because we had been going for onboard drivers, which has been essential. If an error is or exception occurs in the user mode driver, it won't affect the service of the kernel. Okay, that's true, because the user mode software will be placed in the space of the user memory. So therefore, once any error has been coming over there, it will not affect the kernel. If this has been placed, the device drivers software has been placed in the kernel space, if there anything happens, any error, that kernel will not work. So therefore, there is a chances for, that's why we said in the beginning is that user mode is preferable than a kernel drivers, but there is a lot of sophisticated reliability available nowadays in a microkernel which has been designed for special for embedded system, which has been used for a dedicated purpose. If an exception occurs in the kernel mode driver, it may lead to a kernel crash. That's what I could see is that 0 by something, something I said, no, 0 by a error in the divisible point, if it comes to, which is an exceptional errors. So these exceptional errors, if it may chance to, because it's been going through an interrupt to say which sort of error has been occurred. So therefore, these interrupts, there's a chances for a corruption, and it can be wrong triggering can take place the interrupt, because I said that interrupts can be generated, it can be sensed by edge triggers or level triggers. Therefore, that depends upon which sort of a triggering method has been used for the interrupts, which has been used for exceptional errors. The way how a device driver is written, how the interrupts are handled in it, or operating system, target hardware specific. So therefore, definitely when a hardware specifically mentioned, then according to that only the operating system will be designed. This operating system should invoke the particular interrupts which have been handled by the kernel. So therefore, the device drivers is written how the interrupt are handled in it or operating system and target hardware specific. Okay. The device drivers implements the following. One is that device installation and interrupt configuration. That what I said. When you want to invoke any of the device, the initialization has been important. Apart from the interrupt configuration, which sort of interrupt has been generated and what type of interrupt has been generated, which interrupt is going to be given, and what is the priority of the interrupts. These are very, very important to understand the configuration of the interrupts. So this is about briefly about the device drivers, which has been taking a part into the operating system, and where it has been very, very essential to access any of the memory or any of the IO devices by which has been placed in the bottommost layer of the architecture. So above which we have a operating system, above which we have the application software. Therefore, the device drivers plays a greater and greater role, because without a device, I cannot communicate, we cannot transfer any of the information, we cannot do any sort of a task-oriented programs. Therefore, it has been much, much essential for us to understand what is the kernel and how a kernel has been fused with the software of this particular value. Then how it has been generating has been very, very important. Therefore, the device drivers plays a greater role into the embedded system, so that through interrupts only it could be able to access any of the devices. So further and further we will see that when you say the communication is very, very important, because the device, there is a device drivers followed by a kernel. So kernel, device driver, and a device. So between these three, there should be a inter-process communication, and this communication has to be established. Therefore, I can say that the inter-process communication has been going on. So therefore, we have to understand that why inter-process communication is being needed, and what is meant by what type of communication is it? Is synchronous or asynchronous, or the communication has been very, very effective, like that. The exchanging of data and control information has been possible once the inter-process communication is established. How the data transfer takes place, how the controlling of information can be taking place, all these things has to be seen there. Then why process synchronization? What is meant by synchronization? So if processes are acting simultaneously on one event, then how to resolve it? So both are acting concurrent way and synchronization has been achieved, then what for, how to solve the problem? This called as race problem will be coming over here, and how to solve this particular problem. What are the algorithms available for us to understand the synchronization process and its features? They provide critical sections. We'll see what is meant by critical section when you go for synchronization of events, and then ensure the order of the executions. Okay, so order of the execution, we'll just think of it and how to a critical section will be solved, and then how it is going to be executed, and how we'll ensure that the outcome will be a smooth and a success to understand all the events which has been assigned to the process. So now how the process is going to execute in case of any race problem or any sort of a synchronization problem or any sort of a communication problem. These things we'll see it in the next class. Okay, thank you.